Good morning. Say hi, Bones. He's not very talkative this morning. How's it going? So today's lesson, we are going to talk about how the lithosphere has been changing. So we've been talking about weathering and erosion, how the Earth's crust changes from the outside. We've also talked about folding and faulting, how the Earth is changing from the inside. So like we said, the Earth is constantly changing the way it looks. Okay, so let's take a look at some of these changes and what happens as a result of all of these changes. Okay, so one thing you should understand is that mountains can be built by volcanoes. All right. Now, a volcano is just a hole in the ground. That's all it is. It's a hole in the ground that has liquid hot magma underneath. And what happens is sometimes the pressure will build up underneath the ground to the point where the magma will come out of the earth in a very thin spot of the Earth's crust. Okay. It will explode out of a hole. Now, what happens is that when that magma is exposed to the air, we call it lava. When it comes out, now it's called lava. It just changes the name. So magma comes out of a hole in a thin part of the Earth's crust, and it's called lava. Now, what happens is that this lava cools, okay, and when the lava cools, it hardens into rock, and by doing that, it actually plugs the hole that it just came out of. So now more pressure will build up underneath the Earth's surface until that plugged hole now, okay, erupts again and the hole is blown open. And then that magma comes out. When it comes out of the Earth's crust, now we call it lava. So that lava comes out, it cools, it hardens into more rock, and then it plugs the hole again. And this happens over and over and over again, which is why we can get really, really tall volcanoes in different areas of the world that have very thin parts of the Earth's crust. Okay, this is how the Hawaiian Islands were made. The Hawaiian Islands are a bunch of volcanoes. Okay, where Hawaii is in the middle of the Pacific Ocean, it's called a hot spot. All right, and it's just an area of the Earth's crust of the ocean floor where it's kind of thin. So you get a lot of volcanic eruptions, and by the repeated cooling of the Earth's lava, created these nice Hawaiian Island volcanic mountains that exist there today. So it's pretty interesting. So that's one way in which we get volcanoes, okay, and changes, and that's how it changes the Earth's crust, also known as the lithosphere. Okay, remember when land also gets pushed together. Okay, sometimes there's nowhere for the land to go, so it goes up, so it creates mountains. Okay, so it could do it without lava too. We can just get the formation of mountains when the convection cycles or the convection currents, remember, underneath the Earth's crust are going in different directions. We can get mountains, we can get earthquakes, we get all sorts of things happening that we talked about earlier. Now, where are the most common volcanoes? What you need to know is the most common volcanoes are around something called the Ring of Fire. Here's the Ring of Fire here. Okay, these are located on the cracks in the Earth's crust. We're going to talk about that later, how the Earth's crust is broken up into different puzzle pieces. Well, at the edge of the puzzle piece, that tends to be where the thinnest pieces of the lithosphere are, hence making it more susceptible to volcanic eruptions. So we've got here in the northern United States up into Alaska, we've got a lot of volcanic activity, okay, coming across here, okay, coming down from Alaska and across the ocean, coming down the Eurasian plate here. These are all areas of a lot of volcanic activity that we call the Ring of Fire. Okay, so you got to think of that, about all of these different pieces of the Earth's crust being put together like puzzle pieces. Like I said, we're going to get into that a little later. But along the edges, it makes it very susceptible for volcanic eruptions. Okay, we don't have that where we are over here in New York. All right, we're kind of in the middle of one of these plates that we're going to talk about in the future, so we don't have we don't have to worry about volcanoes very much or earthquakes very much. But right around here, this is called the Ring of Fire, okay, which a lot of volcano action happens. Now, due to all that magma moving underneath our feet, remember, if we were a stick on top of a stream, that stick would flow down the stream. Same thing is happening to us. We are basically just on top of a liquid hot magma stream, okay, that's slowly flowing around underneath our feet. Well, as a result of that, we can get earthquakes. Okay, earthquakes are sudden, strong movements of the Earth's crust caused by vibrations that can cause cracks in the Earth's crust. Now, what does this show us? This shows us that our Earth is actually layered. Remember, we have the crust, the Earth's mantle, the outer core, and the inner core. Okay, so this data, this earthquake data, just kind of proves the point that the Earth is made up into layers. The hard outer crust or lithosphere, underneath is the mantle with the liquid hot flowing magma, which can tear apart the Earth's crust, as we can see here. Okay, it's a crack in the Earth's crust. Now, we don't just get volcanoes and earthquakes because of how the Earth is changing, but we can also get plains. Okay, plains are broad, flat regions found in low elevations. Plains usually started underneath the water, and what happens is, over millions of years, due to weathering and erosion, okay, broken sedimentary rock keeps falling downhill because of gravity. Remember, rocks break. That's called weathering. Then they erode. They get washed away. Okay, whether it's by wind, gravity, water, whatever. Um, they're going to find the lowest spot uh, around in order to settle. So this is where the plains came from. Okay, the middle of America, where we have a lot of farming, plains. It's really good for farming because usually the soil is very rich. So when enough sediment settles in these areas, the ground actually builds up to the point where now it's above the water level. Okay, so that you get plains, which are really good fertile soil for farming on. Midwest America, the breadbasket of America. Now, I keep coming back to this idea that we're being shifted around here on top of the Earth's magma. Okay, this actually has a name to it. Okay, it's called continental drift. So we all know what a continent is. We've got a bunch of continents here on Earth, but believe it or not, they actually used to be all stuck together. And what has happened, okay, is because the Earth's mantle is flowing around underneath the continents have actually broken apart, okay, and they've moved away from each other. And we can actually prove this because there is some evidence that shows us that our continents were once pieced together. Okay, the evidence is that if you take all of our continents, they fit together like puzzle pieces. Okay, um, you can see here. Okay, they were all fit together, and I have a picture in a minute that will be a little bit better. They all fit together very nicely about 200 million years ago. And over the past 200 million years, they've slowly started to spread apart. But you could put them back together. Another a piece of evidence that shows that continents drift around. We are all drifting around here on this Earth, however, be it very slowly. Okay, is that they have fossil correlations, and that just means that there's fossils on one continent match the fossils we find on another continent, where we would put those puzzle pieces together. It's kind of like doing a puzzle at home and using color. Okay, there's a little bit of red on this puzzle piece, there's a little bit of red on this one, and they fit together. And that's how you would identify what puzzle pieces fit together. Geologists do the same thing, they just do it with fossils. Okay, so the idea that our continents are drifting around on top of the Earth's mantle is called the theory of continental drift. Now, this single landmass actually has a name. It's called Pangaea. Okay, Alfred Wegener in 1915 was the first scientist to develop the theory of continental drift, and he's just saying that the Earth is changing, and there is great forces here on the Earth that is causing it to change. So here we have Pangaea here. All the pieces of the Earth, or the continents of the Earth, are fit together very nicely. And slowly but surely, you see them start to break apart into what you see now present day here, and what the Earth looks like and the world looks like today. Okay, here's another example of how the puzzle pieces, Africa, South America, Antarctica, India, Australia, they all fit together very nicely. And what he noticed is that there are similar fossils where they fit together. Again, kind of just like putting together a puzzle at home. It's the same sort of thing. Okay, so our lithosphere, and the point here is that our lithosphere and the surface of the Earth is constantly changing, whether it's changing from the outside due to weathering and erosion, or whether it's changing from the inside due to the great folding and faulting internal forces caused by the Earth's mantle. Okay, and when that magma comes out, it could form volcanoes. We can get earthquakes. We can get plains from weathering and erosion. All of this stuff comes together to an ever-changing Earth.